Okay, first question, you have a diagram showing vitamin C. Actually, vitamin C is quite a popular molecule, yeah? A popular molecule to go through. How many chiral centers will there be in one molecule when vitamin C is reduced with lithium aluminium hydride and also hydrogen gas over nickel catalyst? Okay, so what they want to test you, right? They want you to know, right, what are the functional group present. So I've listed over here the two functional group that might be reduced. Okay, the alcohol part we don't really care. Okay, because alcohol you cannot further reduce it. There's no point in uh, focusing on it. So we'll just focus on the alkenes which is present and the ester, okay, in this molecule. So hopefully you don't see the C double bond O and think that is carbonyl. It is actually an ester. So look at the whole thing. Look at the whole thing. It is actually an ester. Okay, so alkenes and ester, lithium aluminium hydride will actually just reduce your ester. Okay, so it will reduce ester, but it will not reduce alkene. All right, so you got to know this. It cannot reduce alkenes. Hello, Xian. Hello. Good of you to join us. Okay, so the other one, hydrogen gas over nickel catalyst. It will reduce your alkene, but it doesn't reduce your ester. Thanks for the like, everybody. Okay, so if you know of friends who need help in organic chem, please feel free to share this live. Yeah, liking it will help to increase the reach, I think. Okay, so you add your CC double bond, right? And if you draw out the molecule, you realize that, hey, if you reduce your ester, right? You know that ester when reduced will cleave into two primary alcohols. Okay, surprisingly, actually a lot of students, right, doesn't know this reaction, yeah? When you reduce it with lithium aluminium hydride, right, it will actually cleave into two alcohol. So if you just think about it, you cleave this C single bond O, right, and then you form two primary alcohol. Then how many chiral center will you have in vitamin C? Okay, so I think if I'm not wrong, there will be one here, one chiral, and there will be a second chiral here. Okay, so there's only two chiral carbons in the molecule after reduction by lithium aluminum hydride. So there's one here. Okay, so with two chiral center, option B and D is possible. Now let's look at hydrogen gas over nickel catalyst, right? Hydrogen gas over nickel catalyst, it will only reduce alkenes. Okay, so if you imagine, right, you go and put in the two H's, then how many of your carbon will become chiral carbons? Okay, so I think there will be one here. Sorry, let me erase the previous one. Okay, so there will be one here, one chiral. There will be another one here. As usual, there will be one here, and there will be one here. So there's a grand total of actually 4 chiral carbons. So it looks like B is our answer.